Hello, these are the 2.1 notes for adding and subtracting polynomials. A lot of definitions are in this section, as they normally are in the first section of every new topic. So we're going to read through some definitions and I'll do my best to explain them to you as we go. The first is for a monomial. A monomial is a real number, a variable, or the product of these with whole number exponents. In example, some may look like just a regular number, a real number. Could look like just something with a variable and no number. Or it could be a product or a combination of these. So like maybe 1/3 AB cubed. So those are all monomials. The degree of a monomial is the sum of the exponents of the variables. So if we were to look at the same three examples that I came up with above, for just a number, the degree of this monomial, since there are no variables here, then this is going to be degree 0. It's the sum of the exponents of the variable. Since there is no variable, this is degree 0. If I were to look at x squared, I look at the exponent on the variable. So the variable is x, the exponent is 2. This is degree 2. For this third example, 1/3 AB to the third. Now I need the sum of the exponents. When I have more than one variable, I have to add these up. So I have A, and there's not an exponent on here, but I know that that's automatically 1. So for this, I've got 1 plus 3, and that's going to give me a degree 4. So remember, sum just means add them up. Definition of a polynomial is a monomial, or the sum or differences of monomials. We call these monomials terms. So if I were to take these three different examples that are monomial, add those all up, that would be a polynomial. More specifically, something with 2 terms is a binomial. Something with 3 terms is a trinomial. Now, the degree of a monomial is determined by the sum of the exponents on the variables. The degree of the polynomial is going to be the largest degree of any term in that polynomial. So let's go through and talk about that in example 1 right here. Name each polynomial based on its degree and number of terms. So for A, I have 3 terms. I have 12x cubed plus 6xy, that's the second term, minus 5, which is the third term. So let's go through and let's look at the degree of each term in this polynomial. So the first term has a degree of 3 because I have an x cubed. The second term, I have an x and a y with no exponents, but those are automatically going to be 1s. I add those up, and that gives me a degree of 2 for this term. And 5 has no variable, so this is a degree 0. So when I look at the entire polynomial is going to have the degree that's the same as the term with the largest degree. So I have degree 3, degree 2, degree 0. Which one's biggest? 3. So that means the entire polynomial is degree 3. It also says to name this based on the number of terms. So if I look at the number of terms, this is looking for monomial, binomial, trinomial, or polynomial. And we have 1, 2, 3 terms here, so we are going to call this a trinomial. Those are the 2 answers to problem A. B, 4a cubed b minus 1/5 a squared b cubed. So let's find the degree of each term. So 4a cubed b. The degree here, I have exponent of 3 and an exponent of 1. So this is going to have a degree of 4. And then for the second term, exponent of 2, exponent of 3 gives me a sum of 5. So whatever one's bigger determines the degree of the polynomial. So this is going to be degree 5. If I name this by the number of terms, I have 1 term, 2 terms. So this is called a binomial. Standard form of a polynomial are when the terms are written in descending order according to their degree. Now in this assignment, it does say write in standard form. You're going to always write in standard form, even if it doesn't specify to. Okay, we're always just going to keep it the same. Another reminder definition here is like terms. So when do I have like terms? Like terms are when I have terms that have the same variables to the same exponents. So you've got to have both conditions met there. All right. So I'm going to go through and I'm going to look for like terms. I've got 7y cubed. And I don't see any other y cubes. Okay, so I'll move on to the next one. Now I've got minus 3y. So I'm looking for anything else that has just a y, just a y, just a y. That's y squared, and then minus 2y. So minus 3y minus 2y gives me minus 5y. What else do I have? I have a y squared here. There's no other y squared, so I'm just going to copy it down. And then I have a plus 7 at the end. Now, in order to put this in standard form, I'm going to put the exponents in decreasing order. So the degree of my first term is 3. That's my largest one, so that goes first. And actually, my next term is going to be 5y squared because it's degree 2. And then I'm going to write my term with a degree 1 and then the 7. Okay. For b, I've got minus 3x. Anything else with an x? X plus x squared is not the same. Minus y squared plus 3x. So let's see. Minus 3x plus 3x gives me, actually those cancel. Okay. Then I have a 4x squared. Now this is a variable squared also, but they're different variables, so they are not like terms. I'm going to write them down separately. I cannot combine them. Now, 4x squared is a degree 2 and y squared is a degree 2. I can't really write those in descending or ascending order. So either way, if you were to write the 4x squared first or the negative y squared first, either one would be correct. Okay. In C and D, I'm actually adding two polynomials that are distinct because of the parentheses. A note here is that we are going to rewrite without the parentheses. So that's your first step. Rewrite without parentheses. Okay. So when I have an addition sign between my parentheses, nothing is going to change. I'm just going to copy down what I already have here and just drop the parentheses. Now, when I have a plus, minus, plus negative x, I could write plus negative x, or I could just write minus x, and then plus 9. I'm looking to combine like terms. So 3x squared, I don't have any other x squareds. 2x, and then I have a minus x right here. So 2x minus 1x's gives me just 1x, and a plus 9 at the end. Check, is that in standard form? Let's see. The first term's degree 2, then degree 1, then degree 0. That'll work. Problem D. I've got these parentheses in here. I'm going to rewrite without the parentheses. So negative 2x squared plus 5x minus 7 plus 3x, and then plus a positive just turns into plus 7. I only have one term that's got an x squared, so I'm just going to write that down. Then I've got a plus 5x and a plus 3x, which gives me plus 8x. And a minus 7 and a plus 7, those are actually going to cancel. So I have no constant remaining. Now for E and F, we have to be very specific here and careful because the difference is that I have a subtraction sign in front of a set of parentheses. And that's going to give me one more step that I have to be careful to do. When I have a subtraction sign in front of parentheses, it's going to change everything in the parentheses after. It's not going to change anything before that. So here I don't have a negative sign in front of my first set of parentheses, so I'm just going to write down 3a squared plus 4a plus 2. And then you can think of treating this subtraction sign in front of the parentheses as, I've heard of students use keep change change, or you could think of it as distributing the negative through. Okay, so I have a minus a negative a, and that's going to turn into a positive, and I have minus a positive 4, so that's going to be minus 4. Go through and combine like terms. I only have one a squared term, 4a plus a. The 1 is not written in front of the a, but remember that that coefficient is understood to be 1. So 4a plus 1a gives me 5a, and 2 minus 4 gives me minus 2. It's easy to make the mistake to kind of overlook this negative sign. So you may want the first thing that you do whenever you look at one of these problems where you have parentheses, a symbol, and then another parentheses, check. Is it a plus? Is it a minus? Is it something else? When it's a subtraction, it's going to change the sign of everything after this subtraction sign, nothing before. So before, in my parentheses, I have minus 5y minus 6, so I'm going to copy that down just as is. My second polynomial that I'm subtracting is 4x squared plus 6. So this is actually going to be minus 4y squared and a minus 6. All right, combine like terms. I've got minus 5y, no like terms there, minus 6 again, and then a minus 4y squared. This one is not in standard form, so I'm going to make sure and double check my degree of my terms here. My term with the highest degree is actually 4y squared, so that's going to go first, and then minus 5y, and then minus 12. The perimeter of any figure is just the sum of the lengths of the sides. So this is just an example of a pretty simplified figure, a rectangle. It says find the perimeter of the rectangle. So we know that rectangles have opposite sides that are congruent. So if my base here on the very bottom is 4x minus 6, and that means my top is going to be 4x minus 6. If my left side is x plus 5, then my right side is going to be x plus 5. And when I want to find the perimeter here, I'm just going to add up all of these expressions. So I'm going to make one long expression here, 4x minus 6 plus x plus 5 plus 4x minus 6 plus x plus 5. There are different ways that you could write this expression. This is what kind of pops out for me. Then I'm going to have to rewrite this without any parentheses. So because these are all addition signs, I can just drop the parentheses and not change any signs and just recopy it without the parentheses. Sometimes I have a different symbol in between the parentheses, and I have to account for that. Right now it's just addition. Now I work to combine like terms. I have 4x, 1x, 4x, and 1x. 4 plus 1 plus 4 plus 1 gives me 10x. Minus 6 plus 5 minus 6 plus 5. You'll see that I always do this underlining thing. If you've got different colored pens or highlighters, you can also use that technique. I've seen that a lot. Whatever makes it easier for you. So minus 6 plus 5 is minus 1. Minus 6 plus 5 is another minus 1. So this is going to be a total of minus 2. Whenever we're doing measurements, we usually include the units. And they don't provide us with the units in this example. So I'm just going to put that in parentheses and call it units, whatever that is. All right. Thank you very much for tuning in to the 2.1 notes.